As dawn breaks and farmers across the world head to their fields, a silent challenge looms large over the horizon. Climate change, an often debated phenomenon, is no longer just a topic of conversation. It's a reality with tangible repercussions. Agriculture, the bedrock of civilizations and the primary source of sustenance for billions, is at the front line of this global upheaval. But how exactly does a warming planet affect our food systems, and what does it mean for the future of food security? Dive into this exploration of the intricate dance between Mother Nature and mankind's oldest occupation, and discover the profound implications for our global dinner table. For many, the term climate change evokes images of melting icebergs and polar bears on drifting ice floes. But to truly grasp its significance, especially in the realm of agriculture, we must first understand the foundational science behind this global phenomenon. Chapter 1: The Science Behind the Shift, Understanding Climate Change Basics. The greenhouse effect, a natural process. At its core, the greenhouse effect is a natural process that warms the Earth's surface. The sun emits energy in the form of visible light and ultraviolet radiation. While the Earth absorbs some of this energy, it reflects the rest back into space. Greenhouse gases in the atmosphere, like carbon dioxide, CO2, and methane, CH4, trap some of this reflected energy, preventing it from escaping. This trapped energy warms the planet, much like how a greenhouse retains heat. Without this natural greenhouse effect, our planet would be far colder, making life as we know it impossible. Human impact. Amplifying the greenhouse effect. The trouble begins with human activities, primarily the burning of fossil fuels such as coal, oil, and natural gas. These activities release large amounts of CO2 and other greenhouse gases into the atmosphere. Over the past century, the concentration of these gases has increased dramatically, enhancing the greenhouse effect and causing the planet's average temperatures to rise, a phenomenon commonly referred to as global warming. The evidence: rising temperatures and shifting patterns. The signs of a warming planet are unmistakable. Since the late 19th century, global temperatures have risen by approximately 1.2 degrees Celsius. While this might seem like a small change, its impacts are profound. Rising temperatures lead to the melting of polar ice caps, rising sea levels, and, crucially for agriculture, changing precipitation patterns and more frequent extreme weather events. Climate change versus weather, a crucial distinction. It's essential to differentiate between climate and weather. Weather refers to short-term changes in atmospheric conditions, while climate represents long-term averages. A cold winter doesn't negate global warming. Instead, we must look at long-term trends and patterns to discern the true impact of climate change. Understanding the science behind climate change is the first step in addressing its challenges, especially in sectors as vital as agriculture. With the basics in place, we can begin to explore how these shifts in our planet's climate directly affect our food sources and the future of global food security. Chapter 2: Fields in Flux. Direct impacts of rising temperatures on crop yields. While the Earth's warming might be measured in fractions of degrees, its effects on agriculture are colossal. From altering planting seasons to affecting the very physiology of crops, rising temperatures are reshaping the landscape of global farming. This chapter delves into the direct impacts of these temperature shifts on crop yields. The physiology of plants and temperature. All plants have an optimal temperature range for growth. When temperatures stray from this range, various physiological processes, such as photosynthesis, respiration, and nutrient uptake, can be affected. For instance, high temperatures can cause proteins to denature and enzymes to lose their functionality, impairing a plant's growth and productivity. Heat stress and flowering. Many crops, especially grain-producing ones like wheat and rice, are sensitive to temperature during the flowering stage. Elevated temperatures during this critical period can lead to flower abortion, reduced pollen viability, and a consequent decrease in grain yield. Such heat-sensitive phases mean that even short heatwaves can have long-lasting impacts on crop output. Shifts in growing seasons. Rising temperatures are leading to shifts in growing seasons worldwide. In some regions, warmer conditions are advancing the onset of spring, pushing farmers to plant earlier. In contrast, in others, prolonged heat is extending the growing season. While this might seem beneficial, it often comes with challenges like water scarcity and increased pest activity. The water equation: evaporation and transpiration. Higher temperatures inevitably lead to increased evaporation rates from soil and water bodies. Additionally, plants tend to transpire more under hot conditions, losing water in the process. This dual effect exacerbates water scarcity, especially in regions already prone to drought. The silver lining: CO2 fertilization. It's not all doom and gloom. Elevated levels of CO2 can enhance photosynthesis, a phenomenon known as CO2 fertilization. Some studies suggest that certain crops, under specific conditions, might benefit from this boost in photosynthetic activity, potentially offsetting some of the negative impacts of heat. The intricate dance between crops and temperature is a testament to the delicate balance of nature. As global temperatures continue to rise, understanding these direct impacts becomes paramount in devising strategies to safeguard our food systems. The challenge is not just to produce more, but to do so sustainably, in a world that's steadily warming. Chapter 3: Water Woes. The interplay of droughts, floods, and agriculture. Water is the lifeblood of agriculture. Its availability, or lack thereof, can make or break harvests. In the age of climate change, erratic water patterns are becoming the norm, with droughts and floods posing significant challenges to farmers globally. This chapter explores the intricate relationship between water extremes and agriculture. The science of droughts. Droughts occur when a region receives significantly less rainfall than average for an extended period, leading to prolonged shortages in water supply. The reasons can be varied, from reduced precipitation patterns to higher evaporation rates due to rising temperatures. Prolonged droughts can deplete soil moisture, adversely affecting crop growth and reducing yields. Impact on soil health. Drought conditions can have profound effects on soil health. The lack of moisture can cause soil to compact and harden, making it less permeable. This means when rain does come, instead of being absorbed, much of it runs off, leading to reduced water infiltration and increased soil erosion. Flooding, the other extreme. While droughts deprive the land of water, floods inundate it. Heavy rainfall, often exacerbated by changing climate patterns, can lead to rivers overflowing their banks or sudden flash floods. Crops can be entirely washed away, or fields can remain waterlogged for extended periods, suffocating the roots and promoting the growth of harmful fungi and diseases. Saltwater intrusion in coastal areas. Sea level rise, another consequence of climate change, is causing salt water to intrude into freshwater aquifers in coastal regions. This salinization of water sources poses a dual threat to agriculture. Not only is saltwater harmful for most crops, but it also affects the quality of drinking water. Innovative water management solutions. Despite the challenges, human ingenuity is at work. From rainwater harvesting to precision irrigation techniques, farmers are adopting innovative methods to manage water resources efficiently. Drought-resistant crop varieties are being developed, and early warning systems are helping communities prepare for floods. The future of agriculture in a changing climate hinges significantly on water management. Whether it's too little or too much, water extremes are set to define the challenges and opportunities of farming in the 21st century. By understanding and adapting to these new realities, we can hope to secure food sources for generations to come. Chapter 4: Pests and Pathogens, the rising threat to global crop health. Every farmer is familiar with the battle against pests and diseases. These age-old adversaries have always posed challenges to agriculture. However, in a world altered by climate change, their dynamics are shifting, often to the detriment of our food sources. This chapter delves into the escalating threat of pests and pathogens in the context of a warming planet. Warmer climates, a breeding ground for pests. Higher temperatures can accelerate the life cycles of many pests. Insects like locusts, aphids, and caterpillars can reproduce faster and in larger numbers when the conditions are warmer. This rapid proliferation can lead to infestations that devastate entire fields in a matter of days. Extended range of pests and diseases. Traditionally, colder regions acted as natural barriers, preventing many pests and diseases from spreading. With rising temperatures, these barriers are becoming less effective. Pests that were once restricted to tropical areas are now moving into temperate zones, exposing crops that have not evolved defenses against these new threats. Increased virulence of pathogens. It's not just the pests that are becoming more of a problem. Many plant pathogens, including fungi, bacteria, and viruses, are displaying increased virulence in warmer conditions. Diseases that were once considered minor nuisances are now causing significant yield losses. Impact on natural predators. The balance of nature is delicate. While pests might thrive in warmer conditions, their natural predators, such as certain birds or beneficial insects, might not fare as well. Disruptions in these predator-prey dynamics can further exacerbate pest problems. Biological controls and integrated pest management. In response to the growing threat, there's a renewed interest in biological controls. Instead of relying solely on chemical pesticides, farmers are exploring ways to harness nature's own mechanisms to control pests. Techniques like introducing beneficial insects or using microbial solutions are becoming integral parts of integrated pest management strategies. The challenges of pests and pathogens are not new to agriculture, but the scale and nature of the threat are evolving in the context of climate change. Understanding these dynamics is crucial for developing effective strategies to protect our crops. As with many aspects of climate change, proactive adaptation and innovative solutions will be key to ensuring food security in the face of these rising threats. Chapter 5: The Human Dimension, Socio-Economic Impacts and Adaptation Strategies. Beyond the fields and the flora, climate change profoundly affects the very backbone of agriculture, the people. From smallholder farmers in remote villages to global supply chain stakeholders, the socio-economic repercussions of changing climatic patterns are vast and varied. This chapter delves into the human dimension of climate change in agriculture, examining both the challenges and the adaptive strategies. Shifts in agricultural profitability. As climate change alters the suitability of regions for specific crops, the economic viability of traditional farming practices is being questioned. Some areas that were once fertile and productive might become less so, leading to reduced incomes and increased uncertainty for farmers. Migration and climate refugees. The challenges of climate change, combined with other socio-economic pressures, are driving many from their ancestral lands. Droughts, floods, and failed crops can force communities to migrate in search of better opportunities, leading to the emergence of climate refugees. This migration can strain urban areas and lead to potential conflicts over resources. Changes in labor dynamics. Rising temperatures can make outdoor work, especially in the fields, hazardous. Heat stress affects the health of agricultural workers, potentially reducing labor productivity. This can lead to increased labor costs, further squeezing the already thin margins of farmers. Innovative financing and insurance models. To combat the uncertainties brought on by climate change, new financial tools are emerging. Climate-smart loans, where repayment terms are adjusted based on climatic events, and micro-insurance models tailored for small farmers are helping mitigate risks and encourage investment in sustainable farming practices. Community-based adaptation strategies. Resilience often starts at the grassroots level. Communities worldwide are coming together to share knowledge, resources, and best practices. From seed banks preserving climate-resilient crop varieties to cooperative water management systems, community-driven initiatives are proving to be invaluable in the face of changing climates. Global cooperation and policy impetus. The challenges posed by climate change transcend borders. Global cooperation, both in terms of knowledge sharing and financial support, is imperative. Policies that promote sustainable agriculture, protect vulnerable communities, and incentivize innovation can guide the world towards a more resilient agricultural future. The socio-economic impacts of climate change on agriculture underscore the interconnectedness of our global systems. While the challenges are daunting, they also present opportunities for innovation, cooperation, and transformation. By placing people at the center of the solution, we can hope to forge a path that ensures food security and socio-economic stability in a changing world. Thanks for watching.